diffusion to make it even faster. Now, before I begin, I'd like to implore you to subscribe, like, follow, and leave comments, because the more of you subscribe, the more the algorithm sends out to more viewers, and those viewers can join this growing community and post either tips and tricks, or they will post requests which I'll research and then I'll share with everyone. Everything is always shared. All right. I just realized this one of these live streams is stuck. Oh yeah, it's just stuck here. So let me take care of this. Just a second here. Okay, that's perfect. Now all the live streams seem to be good. Perfect. All right. Now I'm just gonna do a quick overview in case you missed the afternoon tutorial. So we basically the gist of it, or I forgot to put the intro. Oops, I forgot about that. Yeah, the intro is fixed VAE decoding speed. So that's part of the things we're gonna do. So this is gonna be a perfect way, especially if you have an older GPU or your GPU is no longer supported, or you want to use Vulkan. So I'm gonna show you, or you have an old GPU like I do. So most of the latest optimization are not supported, but the old ones that still work very well, and we're gonna test all of them out as well. As you guys know, I'm obsessed with speed, so we'll see how we'll compare the quality as well. All right, back to the perfect one. Perfect. Okay. So as you can see here, this video is 2 seconds, and I can't remember how long it took, but we'll run it again and we'll see how long it takes, and then we'll compare the speed with the more optimizations. It's already very well optimized. So just make sure you get the latest version of stable-diffusion, either the one that was compiled, pre-compiled, or you compile it yourself. Just make sure you get the latest packages to follow along with this tutorial. I already have them, and you guys saw. I literally this morning, not this morning, this afternoon, I updated everything. I will check again. There might be a night. There might be some new packages. We'll check that as well and make sure everything is running the latest, running the latest application. Okay, so the application is here. It's you go to github.com/leejet/stable-diffusion.cpp. CPP stands for C++. So it's open source. It's using the MIT license. In case you don't understand licenses, I have a dedicated video where I went over the MIT license specifically. And then the Wan 2.1 1.3b, this stands for 1.3 billion parameter model. It's using the Apache 2.0 license, and my latest license-based video, which is actually surprisingly doing very well. I believe it's the Apache 2.0, so you can go watch that as well. Both of them I created a short version and obviously the long version. Okay. Both licenses allow personal and commercial video projects. So what that means that you can use this for anything you want, even not say for work stuff. I don't really care about that. I said I have other users, but what I'm saying is that there's no restrictions on what you can use how you can use the software or the model. Okay, so some of the high performance GPU tricks that we already tried are this one, the diffusion convert direct flag. This it bypasses slow layers to process the video frames faster. So because this GPU, it's theoretically possible to have flash attention, but it's never going to come to this GPU. In fact, some of the other ones like the MI100, they don't even have that flash attention, so it'll probably never come. So you have to come up with little tips, and these are tips I'm helping you with that as well. Another one is this one, cache preset ultra. This keeps the weights already in VRAM. This prevents reloading data during sampling process. So for example, if you have enough RAM, now probably won't be too much of a problem, but I am limited with RAM, and I'll explain that later as well. Another one is this one, VAE tiling. This is really handful. You can also use this for something like Comfy UI. What this allows you to do is it allows you to have a higher resolution, and instead of what will happen is instead of using the slow RAM or the slow swap space, what it will do is it will break up the blocks, each frame will be broken up into smaller blocks to save memory. This is really, really handful. Now, there's a little bit of a performance hit when you do this, but it's worth it because it could keep the majority of the stuff in your VRAM, especially if you have a low VRAM and low RAM. In my case, I have pretty decent VRAM, but you see, I only have 24 gigs of system RAM. So in that case, I'm using quantized models. So this way, try to keep everything inside VRAM, including when it's doing the decoding and all that. So that will be much faster than if it spills over to RAM, which is slower than VRAM. And then if it goes to the storage space for the swap, it's even way slower. So I'll try to, if you're able to keep everything in VRAM, that's perfect. Now, from my particular testing, I found that the Q4K if you're quantizing this stuff, it's probably the best for, I mean, it does degrade obviously from FP16, FP32, but I'm saying is it's the best for where the quality doesn't degrade too much. So I would stick there. Some models, like for example the Z Turbo model, that one you can go lower, even put it to Q2, but I'm just saying that this is not about the case of simply just being able to generate a video or an image. We want to generate at least decent quality or something usable is what I'm getting at. Okay, I forgot to actually remove this. Okay, this is good. This is going to bug me. I'm going to actually, you know what? This is actually going to bug me. I'm actually going to go log in and remove that. I'm surprised it's still there. Okay, I'm going to go remove that right now. Give me a second. I'll log in. Where was it here? Oh, there it is. It's a little hidden little bugger there. Okay, so let me grab this URL. I'm gonna go and remove this. Yeah, it's kind of funny because I've been here like 3 times and I still haven't been able to remove it. Okay, so I'll go remove that. Okay, but while that's going, and then to download the models and the or the model weights, I use this ARIA 2C. This is for parallel download. There's this other stuff you can do. For example, if obviously your system is, if you have a high speed enough internet, you can even use wget curl, just straight up download. All of them will work, but parallel just makes it easier because why not, right? Parallel connection is perfect for that. So I've removed this. So if I refresh, it should be gone. Yeah, there we go. It's finally gone. Okay, and then what else is here? So the other thing is I set it to the Q4K parameter. This also will speed things up, and I'll explain to you why, because I've done testing. You guys actually saw a video, I think it was a night stream I did, where I tested different type of models. What I found for my GPU, the integer 8 is the fastest. After that, theoretically it's supposed to be floating point 16, but it was actually the Q4KM that was actually slightly faster than FP16, that's floating point 16. So after that, then it's I think it's a Q5, Q6, and then FP32 was one of the slowest ones. But what I'm saying is that I'm okay with this, so that's why I put that. So the concession maintains quality while boosting the generation speed. Another thing is to use cache mode easy cache. This setting reduces redundant math calculation. It reuses the previous result. So that means that the more videos you generate back to back to back, it will keep some of the, especially the calculations, especially if you have your the resolution set, like this one here. It will keep all that stuff in cache, and it will be much faster. Well, another one is the flow shift 3. This is poly to improve motion consistency. This ensures, for example, we're going to use a lovely cat example, looks smooth and natural. So that's another reason for that. Now, these screenshots, they're still relevant. Obviously, I'm going to add a few things to this. This is just places where the models are, and I'll show you that as well. As you can see right now, I'm in the LoRa folder. So I'll show you all that, and then running. Okay, then this was the 2-second video. You already seen that running. So this was the previous live stream. Now we have a new live stream. It's an addendum. And I'll show you that as well. Okay, so that's perfectly fine. So we're live right now on BitChute, Rumble, Odyssey, and YouTube, of course. And I'm also trying out, what's the name of this application? I already forgot the name of that. Oh, here it is. It's called Social Stream Ninja. So I'm trying it out. So what should happen is if you guys post some comments, yeah, they should show up somewhere around here where the mouse, I don't know if you guys can see the mouse, your comment should show up here, overlaid here. Okay, now, where am I? Oh, I forgot, I should have actually made a mistake. This should actually have been in the middle. I completely forgot about you if you're joining us using the vertical screen. I apologize. Let me, I forgot about you guys. So let's see, guess I make this a little bit wider. That actually doesn't look too shabby. I guess I make this a little smaller, small again. I think you should be able to see all of that. I believe you should be able to see all of that. Now if you're on a vertical screen, you should see everything. Got to squeeze it a little bit more. It looks like I've squeezed it just a little bit more, like that. Yeah, you should be able to see that now. All right, and then I think I'll just stop here. This is perfect, so I'll just stop right here. Okay, then the project I was talking about is this one here. It's on GitHub. You see it's leadjet/stable-diffusion.cpp. I went through this before, so I'm not going to spend too much time. Essentially, you can go to the, where is it here? You can see the MIT license. You can get the code. You can, yeah. So it supports, as you see, it supports a whole bunch of stuff. The standard diffusion 1, 2, 3, XL, 3.5, Flux, Chroma, Z image, Ovis image, Flux, Wan image edit, Wan 2.1 and 2.2. So click on that one. So I'll show you that. It also supports the back-end CPU, CUDA, Vulkan, Melto, OpenCL, and this one here. This is Intel, CCL. And then the model weight types, you can use the PyTorch checkpoint. You can use Ceph tensors. You can GGUF. And obviously it's cross-platform, Linux, Mac OS, Windows, and Android. If you have, this is for Adreno CPUs. And you can see here, it supports flash attention. Now my GPU doesn't support flash attention. But if you do, yours does, you could use that. Also speed up stuff. You could have negative prompt. And then it uses the stable diffusion web UI style tokenizer, not all features, only token waiting for now. VAE tiling to reduce memory usage. I explained that earlier. Sampling methods, it doesn't support all the ones that come with Conf UI, but this other one supports. And then cross-platform CUDA. Obviously this means, don't get confused, it's not just, you don't have to have a CUDA, obviously that also means ROC, and basically that means if your hardware supports it, all you can do is CPU. Alright, and then you can get the pre-built binaries. I've already shown you guys this on the release page. You guys, especially if you're on Windows, you guys are lucky. You have like Vulkan, you have CPU only, you have ROC M, you have CUDA. Yeah, you guys are really spoiled for that. Even Mac has the silicon as well. And Linux actually, I saw we have Vulkan and we have one which is just the CPU. So I prefer to build from the source myself. Here's the build guide. I've already shown you guys this earlier, but we'll take a look at this as well, just in case some people missed it earlier. And then to download the weights, I'll show you this as well. And then here are the guides. So I already have the Wan 2.1 guide open, and you can see how to use LoRa's. I have this open as well. We'll explain that. And for quantization, I think I don't have this one open, but I'll open it. There's bindings for Python, Golang, C#, Rust, and Flutter Dart, and then have a links here. So let's actually go to, just in case I don't have this one, inference via caching. Oh, this is something new. Let me see what it says. Yeah, so I'm already using some of this as well. I'm using Easy Cache, and yeah. So if you're using unit models, which obviously we are, so you can also set this stuff as well. Here we go. All these parameters. I'm already using this, so that's fantastic. So I'm going to close that now. Just so many windows open. So here is the download weights for the Wan. So we are interested in this one, the Wan 2.1 text to video 1.3. Here's where you get the SIFT tensors. So you obviously need to get that one. And then what you also need is you need the VAE. So I already have this. I'll show you this as well. And then you need a text encoder. So you get the text encoder here. There's also a GGF version of the text encoder. All right, and then this is the command. This is obviously a Windows one. I'm on Linux, so my syntax is going to be slightly different because we don't have exe files. That's Windows only. Okay, and then here some of the results. Oh, there's a LoRa as well. Yeah, I'm going to show you guys LoRa's as well. So this LoRa is obviously for 4B. So the syntax for LoRa's is slightly different than if you're coming from ComfyUI or whatever. So what you have to do is in your prompt, I don't know if there's an example here. Let's see if there's an example. Yeah, see, in your prompt you have to put LoRa and then you put the name of the LoRa here. It's because this one only takes the LoRa folder. You don't specify LoRa, you have to specify it in the prompt, which is perfectly fine. So I'll show you all that. You can see it supports all of them as well. So I'm going to close this as well. Oh, it looks like this is not... I don't know why that is. Hopefully you guys will be able to see that if you're in a vertical stream now. I don't know why that game... Okay, so as I said, when I download the releases folder, you can obviously see here the assets. This is the latest version. It came out 3 days ago, so because I updated earlier today, so I do have the latest version, which is the master 4.71 at the time of this recording. Okay, and we have, as you can see here, you have this one for Windows. This is CPU only, and for Darwin, that's obviously Mac OS. It's ARM64, Vulkan for Linux. Even though it says Ubuntu, this works on any Linux. I've tried this before in the past, and this one is also CPU only. So you can get this one, or you can get the Vulkan one. And for Windows, as I said, you guys are spoiled. Look how many you have here. You see that? You have AVX, AVX2, you have AVX512, you have CUDA, you have no AVX, you have ROC M as well. I said you guys are really spoiled, and obviously you can get the source code as well. All right, now I'm going to close that as well, and then to build it, here are all the instructions to build it. If you want to build it for CPU only, if you don't have a GPU or a CUDA install, you can build it for CPU only. I don't recommend doing CPU only. If you're going to do that, I highly recommend to use OpenBlast. OpenBlast is basically yeah. So use OpenBlast. OpenBlast is will speed things up. I've actually compiled it for CPU only when I was having some issues, and then when I used OpenBlast, big difference. I think I got like 40 to 60% improvement. So definitely don't just compile for CPU. Get the OpenBlast. I mean, unless obviously your CPU doesn't support OpenBlast, which I doubt, so get that. Now, if you're doing any of the GPUs, you don't need OpenBlast because they have, for example, CUDA, it would be way faster, and ROC M, this is the AMD one, it has something called HipBlast, so it's a replacement for that. It's faster. So that's a CUDA one. HipBlast is here. This is, I said, the ROC M AMD GPUs. So I have an AMD MI60, and this one does work. What else is here? Musa, this is the More Threads GPU. I've never heard of this or seen it. This is the toolkit, okay. Metal, I know that's Apple. Silicon. Vulkan, obviously, you can also do Vulkan. Vulkan is actually very good for images. The only problem is, I don't know if it's a GGML. It has restriction, I think, in how much VRAM. I don't know if that's hard coded somewhere. I think it's hard coded maybe in the GGLM. I think it's hard coded 8 gigs or something, which is because this loads models really fast. It was a shame because I was not able to. I guess for images you can try this. Vulkan obviously is also supported on I think like all CPUs. You can run that as well. But if you have an old GPU that you can't run, for example, ROC M or CUDA, try Vulkan. You'll be pleasantly surprised. Hopefully the 8 gig limit has been lifted, because this is really good. I'll try it again in the future, especially when my GPU also becomes no longer although it's open source, the ROC-M, so I think I'll always be able to compile it. All right, and then the OpenCL for Arduino GPUs. You can see here how to instructions over here as well. So this will be, I guess, for ARM. This might be for ARM type of GPUs as well. And then this one is for Intel GPU. Okay, it's a one API. Okay, I guess that's their short name for that. It's a kind of weird name. Okay, so they can compile as well. All right. Next here we have the LoRa's. I already explained how to use LoRa's. You basically download the LoRa, and then what you do in the prompt is where you put the LoRa. You see it's a LoRa tag here, and you whatever the name of the LoRa and the I guess the number. Usually it's set to 1, and then you can see here it's a little bit different, I said, than ConfUI, because all you do is you tell it where to load the LoRa model dir, the directory, and that's it. And then it says here there are 2 ways to apply LoRa. You can apply it immediately and at runtime. You specify it with the LoRa apply mode. So by default it will be applied automatically, and I'm okay with that, so we'll try it, but I don't think it will make a big difference. Immediate mode may have precision and compatibility issues, so that's what I said. I'll leave the auto. All right, so we have that, and then okay, here where I grabbed all the models. You can see here the Wan 2.1 ConfUI repackaged. So obviously I went to the quantizations here. If you go to files, and you can see this is where you go to split files. Excuse me. You see there's LoRa's here. There's VAE. So you can grab the VAE. You see this is the one you need, the 2.1 VAE safe tensors. So let me go back to split files here. Then there's LoRa's. There's this one, the one alpha. This is obviously alpha, like the name says. It will give you RGBA. The A is for alpha. So I don't need that one at this time anyway. So, and then there's the text encoders. You see there's 2 text encoders here. There's the FP16 and FP8. Now, for some of you guys with consumer grade GPUs, you most likely want this one because it will be lower. You see it's much smaller. It's almost half size, and it will if your GPU supports it, definitely use it. See, my GPU doesn't support this, so if I was to take this text encoder, I would have to get the FP16. If I use this one, it will be slower because it will have to take all these numbers and convert them into FP16 or FP32, so it's going to be really, really slow. Even though it's small, it should be, yeah, my GPU doesn't support floating point 8 or 4. So that's why I'm better off getting a quantized version like Q4 or Q8. Okay, then we'll just go back to split here. Then diffusion models. You just look here and you grab the 1.3. Here you go, text to image. So I wouldn't get this one as well, BF16, because my GPU doesn't support the BF as well. So this is one I would get. You see, it's only 2.84 gigabytes. So this one is definitely fit. This should fit in any poly, even if you have a 4 gig. What do you call it? A 4 gig GPU. Now, obviously, be careful with that. If you only have one GPU and you're using it to load up, monitors, you're running other applications, so I'm saying is this might be tight, but I've heard people who are able to actually get it to work. But that's why you look for something else, like maybe look for maybe a FP8 to definitely be smaller, or get a quantized version. I'll show you that later. Okay. Now I can easily fit this this guy in my GPU because I have 32 gigs of RAM. But I said I'm also going for speed, so I'll show you what I decided to get instead, or to try instead. So let's go back to split files, and the other thing you need is, that's it. You just need a text encoder, you need a VAE, and you need the diffusion model, and I showed you where to get them, so that you can get them as well. And then if you want to get the GGUF versions, you can see there's several of them here. We have obviously the 16-bit ones, and so these are different files. This is kind of weird, but you can see you can start with even here they have 2-bit ones. This will probably be terrible quality, not even worth it. I mean, if you just for giggles, maybe you want to try it, sure, but I would not start. At least, as I said before, start with a KM, Q4 KM. Some models, like for example the Z Image Turbo, you can actually go right down to the 2. You get very decent quality. What I'm saying is, there's a lot of loss. You have to remember, these models usually start with FP16, which is half precision. So when you as you can see, when you keep on going down here, you lose a lot. For example, just here, this is already half precision, right? So if you go from 16 to 4, that is 4 times. Right, so I'm not saying it's 4 times the coil loss. I'm just saying there's a lot of stuff lost there. So once you go from, for example, here to a 2 compared to this, that's 8 times, right? So that's a massive drop in, and you definitely see some artifacts and stuff as well. Okay, so what you do is you go to files here, and as you can see, there's several of them here. You just look for. I was using this in Paint in Comfy UI, but just look for the 2.1. Here we go. You see this one? This one will probably. I wouldn't even. Yeah, you see they're pretty small. It's less than a gig. So I'm saying if your memory, if you don't have enough for VRAM, you can try that one. The M stands for medium, in case you're wondering. So this is the one I got. This one you see 2.1 text to video 1.3 Q4 KM. You see the size is just barely a gig. So that's one I got. So what I'm saying that this will easily fit if you have 4 gigs of VRAM. I'm actually, you know what, if my old workstation still came with 2 gigs, it's an NVIDIA GTX 950, I could probably be able to get away with this guy as well with a 2 gig. But I was also using it to power the monitors and stuff, so this would be really, really, really tight. But yeah, there you go. You'll be able to run it. The irony will probably be faster too, because it was still supported by CUDA, I think until 2025 officially. So last year. All right. So what else is here? Is there anything in the files? Yeah. So that's where you get the GGF. It says right there. I didn't even pay attention. And then you can also get the text encoders. There's also GGF versions. You can see all of the sizes here. You see there's 3-bit, 4-bit. I got the 4-bit. I got the 4KM. You see it's 3.66. So this is where if you have RAM, the text encoder is only used right at the beginning. So if you're able to, if you have enough RAM, that's perfectly fine. So in my old workstation, I had 16 gigs of RAM. So definitely I'll be able to run this on my 2 gig VRAM. It will be a little bit slow, but it will definitely be able to run. So this is one of the great things about this 2.1, 1.3. So you can see there. Now, as I said, I can also run this one, the Q8. It's 6 gigs, and I can also run the FP16. I would not run this FP32, even though it fits on my GPU. The problem with this one, obviously the quality will be much better, but the problem is you need to leave a little bit of space when it's actually doing the decoding and all of that as well. So just because it's able to fit doesn't mean it's a good it's a good fit, right? So just be aware of that. Now, if this was in Comfy UI, I would definitely probably try this one, because you have things like purge memory, better tiling options as well, or more, I should say more, not better. So this is the one here, and then this is I went to Civic AI. I just typed in Wan 2.1, 1.3b, LoRa, and then this was actually for my Comfy UI workflow, and I got this LoRa. You see this one here. This is a distilled LoRa. So basically, what that means is that it's for less steps. Right, distill means it's fast. That's what I remember. I said that we're all about speed here. So as you can see, I actually ran this in Comfy UI. Did I do a Comfy UI tutorial? I can't remember. It looks like I. Oh yeah, I did do a Comfy UI tutorial, but I haven't shown you the video. I only showed you guys the Z Turbo image and the fan one. But yeah, so I have actually added this distilled one, and yeah, it is fast. So yeah, so here we go, and yeah, so this person also took, where is the image? Is it this one here? Let me see. There you go. You see, this is the video, or this animation. You see that? Can you believe that? That's from the 1.3 Wan 2.1 1.3b model, right? So you can see there. Okay. Yeah, that's the little small model, and this is the workflow. So I wasn't sure where to put this model, so what I did was, I'll show you this. I'll open a new tab, and I'm going to zoom in. Okay, it looks like control key. So because online everybody was putting, oops, if I should have, what is going on here? I think I grabbed the wrong model, the wrong one. I zoomed in the wrong one, but okay, I think I need to go here. I zoomed in the wrong one, but this here is where the this is, oh, again, I did it again. Jeez. Okay. I don't know why it's low. Oh, I think it's this browser. This browser doesn't do it properly. But basically, in case you're wondering, when I searched online, most people are putting the LoRa here, but this one, the LoRa is actually just before it goes to the K sampler. So I was like, and the way this LoRa was being used is it's for the second K sampler, but I wanted to do things in one step. I wanted things faster, so you can put it. So I just put it in the first one here, just to speed things up. I was like, I don't need, because what I'm going for a claymation look. I'm not going for a realistic look, so I don't care about, like, obviously this is meant to be like a high noise, low noise type thing, like the Wan 2.1, the bigger models, the 14B, and the Wan 2.2 14B models do. But I said, for me, I don't need that. I'm just more interested in speed. All right, so that's that one there. So that's from Civic AI. You can go anywhere. You don't have to go to Hugging Face. You notice the before and Hugging Face anywhere. Some of them are even on GitHub and other places. You can find them. So next, I'm here just to show you that one of the reasons I use Fedora is you see all these packages, these AMD packages. You can see RockM, everything here, and I'm gonna go down here and I'll show you something interesting. You see, it says hardware support. Now, Fedora 44 is going to be released later this year in spring, and if you notice here, my GPU is right here, GFX 906, right? So that's fantastic for me, right? Because obviously not all packages are going to be perfect. You can see here, for example, this RCCL, you see it says limited GPU support for that one, and is anything else there? No, that's it. So obviously, this is going to have, I think, RockM 7.1. Remember, the GPU, AMD officially dropped support for my GPU on RockM 6.3. So right now I'm on Fedora 43, and I still have RockM support, and I'm going to have it in 7.1, because I said that's the good thing about open source stuff. You can compile it yourself. Obviously, I won't get all the latest, greatest features like the diffusion, what is it called? Diffusion attention. What is it? Attention diffusion. Flash attention. Obviously, I don't get flash attention, and most likely never will. So, but that's perfectly fine. Obviously, I don't think this is no longer in support. This is probably going to be end of life soon, if it isn't already. Oh, this is going to be end of life when, I guess, 44 comes out 1 month later. So, yeah. So that's it. I just wanted to show you this. You see, I'm on Fedora, so all I need to do is just DNF install RockM and just the user mode here, and that's it. That's all I need to do. And I'll run these commands on the command line as well, just to show you how everything works. Okay, so that's a Fedora. Now, I've always said this: before you run any AI, know the limitations or the pros and cons of your GPU. Basically, is what I'm getting at. So you need to understand why it runs slow sometimes. Don't just simply copy paste. Don't do a copy pasta of what you guys find on the internet. So for example, if I go here, this is from the AMD official AMD website, and you can see here, these are the options here. This part doesn't really matter. I'll show you that as well. I wish they had that fixed heading there. So you can see here, my GPU is this one here, MI60, right? So you see it was released in 2018, right? So not too old, honestly, for a GPU, but it's Vega 20. So this is one of the reasons that AMD decided to drop support for it, because it's a Vega 20. Oh, this is not, oh, is it here? Okay, looks like I have to do this the hard way. Okay, so it's a Vega 20 now. You can see MI60 here. It was running on the TMC 7 nanometer. That means absolutely nothing to us. So I'll show you one of the problems with this particular GPU, as I said. So if we keep on going here, you see here, if I scroll up, I'm wondering if this heading will show up here. It doesn't. So it says compute units, right? So these are the compute units, the matrix cores. This is what I'm trying to show you. So my GPU doesn't have any matrix cores. You see this? Only the AMD Instinct MI300A and above have the matrix cores. So that's very, very important. When you see people saying, oh, use matrix attention or blah, 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 yeah, it's not going to work on my GPU. So that's what I'm saying. Make sure you know, don't just do a copy pasta. Obviously, it has compute units, has a peak engine here. Let's keep on going. And you see this one, 4-bit. I know it doesn't have 4-bit, so I'm not even going to bother scrolling down here. And this one, you see the matrix stuff. See, anything that has matrix, it doesn't support it. You see, even that one, it's only the MI350X and above which do support that stuff. So you see here, it says the micro-scaling matrix. Again, I know my GPU doesn't support this. I'm not even going to bother looking there. FP8, obviously my GPU doesn't support any FP8 as well. So the point I'm trying to tell you guys is that be sure to understand your GPU very well. It will save you time and headaches, because you'll be running things like, see this stuff. That stuff is clearly not supported on my GPU. FP16 half precision matrix, again, that's not supported on my GPU. So let's keep on going. So stuff like this, you see this general FP16. This one is supported on my GPU, and I can prove it if we keep on going down here. You see MI60. MI60 here, that one is supported. So and then you see the half precision. I think this is a matrix one. This is clearly not supported. Yeah, you see that one is not supported. I know that's a matrix one. Anything that's not supported is matrix. You see anything with matrix, that's not supported. And we can see down here another stuff here. Oh, this is you see this one peak. This is matrix stuff. None of that stuff is supported at all. Here's another one. This is a matrix. It's FP16. That's clearly not supported. You see, it only if you have an MI 100, you guys are lucky. I lucked out, if you will. And here's something that I'm supported, which is just the peak single precision FP32. So that one I am supported, not too shabby here. There we go. The GPU, I thought they did this one. Oh, it's a matrix. That matrix doesn't. Just the regular one, it is supported. Yeah, you see this one is the regular one, the FP double precision. That one, it is supported, and it's right here. And you see the integer 4. You're right, integer 4. That one is not supported. Now, if you have an MI 100, you are in luck, because that will just fly if you do have integer 4. So meaning that even the quantized models, will fly on that one. So would I get this card? Obviously, this one is not going to be supported too much longer. I'll probably, if it's cheap enough, I'll definitely get it for the integer 4s. Oh man, I'll have so much fun with that one. Yeah, and integer 8 matrix, obviously, it's not supported by the matrix. Anything with matrix, none of that stuff is supported, so I'm not even going to bother. but the regular integer 4 I do have. You see MI60, that one is supported. And yeah, integer 4 matrix stuff again. Come on. That one is clearly not supported. I think that's, yeah, BF, remember I was telling you about BF16, that's clearly not supported on my GPU. So I think that's about it. Yeah, so none of this stuff, you see only the MI100 supports that, so I can't, I mean, it will convert it into F16, which will be, so you get a performance hit as well. So none of this stuff is supported. Yeah, and then obviously the power, yeah, this part is not really important. Yeah, HP, whatever, who cares? All right, anyway, so what I was trying to say is that, yeah, so the rest, yeah, this is the end. So I believe this is the end. There should be no, oh, I was wrong. So you can see none of this stuff is cooling. Obviously, there's no cooling here. There we go. So it was MI60 here. Here we go. Obviously Linux, whatever. So that's what. Now there's also a dedicated page for the MI60. Just a quick summary here. What it is: Vega 20, Steam processors, compute units. So this is the information salespeople will tell you. Oh yeah, the floating point 16, FP32, FP64, and integer 8. Right? So that's what you fall for. But I'm saying if you dig deeper, you understand why. Even with this, which looks really, really good. But the point I'm trying to say is that I found two models which were actually fully integer 8. So this thing just flew. What I'm saying is that's very rare. Most of them will have a mixture of FP or even BF16. So just be aware that if you can find one is fully integer one, sometimes it's a mistake, but if you find that's fine. I mean, depending on your GPU. So I'm saying once you know your limitations, you can then work around it. Now, the good thing is it has 32 gigs of RAM, and it's very fast. Its memory clock or the bandwidth here as well, or 1 terabit per second. So this is actually very good. You can take advantage of that if you had memory. I don't have a RAM, so if I did faster, it would be really nice, but I don't. Anywho, so that's all I wanted to show you guys. Now let's actually get started here. So I have downloaded the models here. I want to show you this as well, just so you can see what's going on. So as you can see, I have this LoRa. I put it in the LoRa folder here. I have where is it? I also have the regular VAE 2.1. There we go. This is Comfy UI folder, by the way. And then we have this this one here. This is for the Tiny encoder. We're gonna try that out for speed. To replace the VAE. What else do we have? Oh, text encoders. You see, if we go to text encoders, I have a whole bunch of text encoders here. You see, I have the Q4KM. You see, the file size is 3.7 gigs. I have the regular Q8 as well, which is 6 gigs. I have the FP8 one. That's the one that Comfy UI recommends you get, if right? But it's about 6 gig. Now, the problem is because it has the floating point 8. Remember, my GPU does not support floating point 8, so I would not recommend using this one. However, you can get the FP16, but you see FP16 is almost double. It's pretty big. So this is actually much faster on my GPU than this one. For most of you guys, you'll be like, what are you talking about? FP8 should be faster. Right? But I said my GPU doesn't support FP8. If I run this, it's going to convert all of this to FP16, so it's going to be much slower. So as I said, be sure you understand your GPU and pick the thing that's appropriate for your GPU. Now, as I said, I also have this guys here. So what I'm trying to say is that instead of me getting this one will be faster, this one will be faster. Yes, this one will also be converted to FP16 as well, but it's actually much faster than this one on my GPU. Okay, then I think we'll go to UNet. So UNet here, you see I have the quantized version of this one. You see it's only 1 gig. It's a Q4KM. I also have the Q8 version, and what else do I have in here? Okay, those are different ones. Yeah, so you notice I don't have the FP16, right? So I got rid of it because I did test it out, and I was pretty happy with the result for this one and this one. So that's why I stuck with that one. I didn't see any I didn't see too much of what do you call it, degradation. So that's why I left it. So that's where we are now. Let's go here and get actually started on the command line. So I'll show you why I have two of them here. This one is for the cooler, because remember this GPU doesn't come with a cooler, so I use a fan shroud and a what do you call it, 40 millimeter fan to cool it. So this one I'll have to run in a separate. I'll put it here. I'm gonna make this a little bit. Oh, come on! I'm gonna make it smaller because you don't want it to be in the way here. There we go. So I just go to one here. Yeah, perfect. Yeah, I think it's perfect size. I think this, yeah, so we have this system fan too. So I'm just using a case fan. So this one is the one that cools these. This is the dedicated GPU, this is the integrated GPU. So you see that on idle, it's about 42 degrees Celsius. Now, this GPU does come with one display port, so I could theoretically use it to power my two displays. I have a 4K monitor and I have a 1080p. I'm using the 1080p for this screencast, live screencast. So all I do is I control this manually. The reason is because the fan is loud. Because remember this is a server grade GPU, so it's it needs cooling. It's meant to be on a server, right? So the server is the fans will definitely cool it down. But for your home or your office, it's very loud. So I prefer to control it manually. I do have a script, but I don't use it because what happens is the temperature jumps up really fast. So I'm afraid that my script might not be able to kick in as fast. So that's why I just control this manually. Now you could also set this in BIOS, but in BIOS you would have to leave it on very high or whatever. So on BIOS I just leave it at about 2%. You see, just below 3,000 RPM. So that's for my own sanity. I just don't like the noise. All right, you guys are lucky too. You probably won't, even when I put on 100%, you guys won't be able to hear because there's some noise cancellation. You would hear the annoying noise. All right, so this is what this application is called, Cooler Control daemon. It's an app image. So and it loads up in the browser here, and I control it there. That's what that's for. All right, now back to the command line. I'm gonna go one further out, just to show you what I do. So I'm gonna do an update. There should not be any there shouldn't be any updates, but you never know. So I doubt it, but we'll run it. We will run it as well. So let's see here. I've done all the links. I've shown you my AMD. Oh yeah, I forgot. Before I do that, let me run rockminfo just to show you that it is installed. What I did is I just did sudo dnf install rockm. That's all I did. Okay, now just type rockminfo, and you can see this comes up. And remember, we're looking for the GFX 906. Once we see that, yeah, here you go, see 906, so it is supported. The other command you can run, rockm cmi. I'll run that one as well just to show you. You see it because there's the integrated. Remember, I'm using a Ryzen 5 5600 GT, so it integrated graphics and the dedicated graphics. The integrated graphic is to power the monitors, but it also takes 4 gigs of my system RAM. Yeah, had I known that, I should have simply just paid more money to get or even keep my old NVIDIA GPU instead. Anywho, so and save some money. Anyways, the point is we have this what do you call it? The yeah, so the 0 is the dedicated GPU, and no, yeah, 0 is the dedicated, am I right? Yeah, 0 is the dedicated GPU, 906 here, and this one is the integrated. 1 is the integrated GPU. As you can, so it always has 90C, that's the CPU, obviously, that's the one here. And now to see how much VRAM I actually have, so this is another command you can run in case somebody tries to cheat or lie to you. You simply run this command here. Oops, wrong one, I forgot the R at the beginning. You see here the VRAM, 32 gigs of RAM on GPU 0. Remember, that's the dedicated graphics, and the integrated one, it says 4 gigs here, so it grabs 4 gigs of my. I only have 32 gigs of system RAM, so 4 gigs is actually pretty big as well. Anyway, so that's the system there. So I'm in right now for PWD. You see, I'm in the stable diffusion folder. So all I need to do is do a git pull. I'm doing an update. Git pull, I'm already updated because I did this earlier today. So, and then what you need to do is you also need to make sure that the you also need to make sure that the other package, remember the GGUM, that's also important. You have to make sure that's also up to date. So I was surprised there was actually something earlier today, but there's nothing. So everything's up to date. So I just go to the build folder, and you can watch the earlier tutorials. I've done this several times. So all for the instructions I showed you earlier. All right, and then if you want to see all the available commands, you just say bin/sd cli and then -h, and you see these are all the available commands. Now some of these commands you guys already know. You see, like we're using you see the ultra here, the cache preset. We're also using the easy cache, if you remember, and you can also skip layers and all this Euler A for the those are schedulers. Yes, you can set the schedulers here, and this is the sampling method. So you can sampling method and the schedulers here. So you can see you have a whole bunch of options here, and I've already showed you the Euler, not Euler. What do you call it? The VAE and all of that. It's all here. How to load all of those stuff here, and of the tiling. You see all the options are here. Okay, so now with that said, let's actually do some tests here. So let's go to, I need to get out the config folder here, stable-diffusion. Where's stable-diffusion here? And we're in the build here. So I already ran. So this is the video that. So this is the video that we created in the tutorial. This one, number 7. So I'm gonna generate one again, and that will be the base to compare the speed and it's already optimized very well, but we're gonna check the quality and compare it to all the stuff we're gonna do today. All right. And yeah, so I've shown you all that. Now let's go and show you my prompt, and I'll explain it. It's the same prompt as earlier, except the output, I'm just changing it. So I'm going to zoom in here so you can see we're running obviously the application -m, meaning what type of generation are we doing. So obviously it's video generation. The diffusion model, as you can see, it goes in the config folder, unit. We're using the Q4KM GGUF. The VAE, we're using the Wan 2.1 VAE safe tensors. The text encoder, we're using the Q4KM GGUF. And our prompt is a lovely cat. Ooh, this is actually wrong. This one doesn't have a LoRa. I need to remove this LoRa here. Yeah, that's the problem when you copy paste stuff. Okay, this one is wrong. I'll remove it. Actually, you know what? Let me remove it because this is wrong. Yeah, it's a good thing I caught that. Yeah, there's no LoRa here. Okay, so let me clear this. I did a find and replace. I didn't realize that I did that. Okay, so here we go. So here's the prompt. It's just a lovely cat. That's all it is. The CFG scale 6.0 sampling method Euler -v is for verbose, meaning that the more information we put out on the screen. The negative prompt, I use the default one. This is in kanji Chinese, simplified Chinese, I believe it is. So what this it basically says stuff like no extra limbs, good quality, stuff like that. And then the width is 832, the height is 480. This is considered 480p. This is where it was trained on. So the weird thing is, it's actually fastest if you use the same settings where it was trained on. So I left it like this. What I noticed is when I try to be smart and use different sizes, the quality was actually really bad. So and the speed improvement wasn't even worth it. So you just get a bunch of noise and stuff. So I'll leave the default size here. And I said instead what I focused on is things to improve the speed output. So video frame, set it to 33. That's about 2 seconds. Because it's by default it's 16 frames per second. That's also what it was trained on. So Wan, for some reason, the math is usually you have to put one extra pixel there. I've noticed it actually does a difference. For example, if I put this as 32, it will still be 2 seconds, but it will kind of be a little bit jerky. So it's always, yeah, that's another thing with Wan. You always put an extra. Just put an extra. So here instead of 32, I put 33. That makes a difference. And then flow shift at 3.0. Here's where we start doing the optimizations. Everything except for the output here, which is which one here? This is just the output, whatever the file name will be, is about optimization. So this was the optimizations that we did earlier in the article. VA tiling, cache mode, easy cache, cache preset ultra, diffusion, convert direct. So this one is important because this one doesn't have a flash attention, right? This GPU, and you're never going to get it. And then VA obviously convert direct. The reason we do this is because I have enough VRAM, so you don't want to do like CPU and whatever. There's enough VRAM. And VA tile size set to 128 by 128, and then the type Q4, because remember our models are all Q4, so that would be I might be able to get faster with FP16 or Q8, but I don't want, there'll be more RAM and more VRAM, so want it as fast as possible, and I say this is fine. And then obviously the output file. So that's it. So let's run this. Alright, so while that's running, I'm going to set this to 35. And you can see right now the temperature is 43. It will jump up soon. So here's the verbose. If you want to take a look at this. So this is obviously, you should see some stuff. Yes, it will load all that stuff later. I'll show you. I'm talking about my GPU and everything. So you see the output path here. There's no preview.avi. Obviously, I didn't set it. That's the path, and you can see the text encoder here, the diffusion model. There's no high noise VAE, and we can also use the tiny encoders. We'll try that as well, and we'll compare the code. You see the type, I set it to Q4 K, and the flow shift here, C3 offload parameter CPU. I don't want that. That's going to be slow. Control net CPU false. You see those are all false. Diffusion attention, it's false because my GPU doesn't support it anyway, so it'll be useless to do that. And then you see direct convert set to true, VA convert direct set to true, circular true. You see all those are defaults. And the tiling parameters 128, and what else is here? And the prompt, the negative prompt, and some of these are defaults. And so it's going to skip some letters, 7, 8, and 9. Yeah, those are all defaults as well, or based on what I have. So I'm not using a VSC version. And fail to open what? Oh, I thought that was okay. This is just a warning. It failed to open. I was like, what is going on? So it's going to try it with the GGUF reader. So it should be able to load that up. yeah, so everything went well. You see what I was telling you about? Like, you're not gonna get a perfect Q4 model. You see, even with all of that, you see those models still have example. Even though most of it is actually not even most of it. Look at it. This model, it's Q4. Remember, it's a Q4M, so it has 354. But you see the other weights. The most is actually FP floating point 32. Now, luckily, my GPU supports. I think all GPUs do support FP floating point 32, so I'm okay with that. But you see, this is the dreaded. This BF16, not the worst thing in the world, but yeah, this is definitely going to be a little bit slowing down, because remember, the GPU doesn't support that naturally, and clearly the GPU also doesn't support Q6. So this is why if running this, if I use the FP16 model, it will actually be much faster for my GPU. That's why I'm saying that just be sure you understand the limitations. And see here, the same thing here. At least this one, most of it is Q4. So this one is probably very good. This is pretty good for my GPU. This should be fine. This one should also be fine, because there's no BF16s and stuff here, so this should be fine. This should be fine. This one is a problem because the VAE. So that VAE is a problematic one. I should probably use even if it's a FP16 one. So this one is going to be slow. So we already know, this tells us the slowest step is going to be the VAE. That's going to be the decoding part of the VAE. Okay, and then we run here. So it's using, you see, it's not using that much VRAM. It's for the text encoder used about 7 gigs, and then the what is this one for? This is another about a gig VRAM for the tensors. And you see the VAE used. VAE is very small, so it doesn't use that much VRAM. But that BF16 is going to be a problem, and yeah, that VAE is going to be a problem. So it loaded the what is this one here? The text encoders were loaded. See, that's decent speed, iterations per second. This one is the VAE, again, that is okay, that's fine. And this one is the VAE. I'm kind of, yeah, it's kind of small, I'm not sure which one is it, but yeah, those are pretty good numbers. Then what had happened here? So it loaded everything, and it's hard to read this, but yeah, so VRAM, I'm okay. I'm about 32 gigs of VRAM, so everything should stay in VRAM here. So we go here. It's done. It's finished, by the way. Me talking, it's actually done. So total it used is about 9 gigs of VRAM. Right? So use easy cache. Remember, I've run this before, especially even earlier today, and plus I didn't have actually close any of this, so it's probably still loaded in VRAM. So it went here, used the easy cache. It skipped 11 steps, so that is massive. Remember, it's 20 steps, so it skipped 11 of them. So that's fantastic. That means it only ran 9 steps, and look at that speed. See, estimated speed up, fantastic. So the sampling step only took 219 seconds, and then it completed generating the latent video in 219 seconds. And then the VAE, you see the VAE was very, very slow. It took 47 seconds per iterate. That is slow. So I said I know why, because it's that BF16. It's not the Q4, it's not the Q6, it's that BF16, because the GPU doesn't support it. That's what I was telling you guys. Know what your GPU is, limitations of your GPU. But even with all that, it still didn't take too long, and then the total time for generating this video was 26793. So if I could get rid of that BF16, I would probably be able to get it under 200 here with this current setup. That is still very, very good. So is the quality any good? So let's go check it out. Remember, it's a 2-second video. So let me actually, this is going to be annoying me a little bit. Okay, so let's check out the video quality. So I'll play it. It should play in the middle, so if you're in a vertical screen, you should be able to see that, no problem. Come on. Okay, I didn't expect that. Okay, so there we go. I'll play it again. Can I zoom in? Yeah, there we go. Okay, so let's play the video. Yeah, so not bad quality. So that's a Q4 mode. Obviously, I said if I was using a Q8 and the FP16, it would be even better quality. So that's not bad. Not bad for, what is that, 200, and I think earlier today when I did this, remember I also have OBS running, so if I didn't have OBS, it would actually be faster too. So 267 is not bad. That's just under, is that 4 minutes? Oh no, what is it, 267 divided by 60. Yeah, it's under 5 minutes anyway. Yeah, it's definitely under 5 minutes, about 4.45 minutes. So that is decent quality. I mean, for that speed, but it's a 2-second video. So what I'm going to do is we're going to use that. This is going to be our, remember, this is also cache, so it's actually, you know, this makes it look much better than it really is. But that is good, and the quality is decent. So I'm going to keep this mode around for prototyping, and then I will okay, so that's basically the same thing we did earlier today. Now let's move on to actually do some fun stuff. So I'm going to put a LoRa. I'm going to use the same thing, but I'm going to use the LoRa. So we're going to compare the quality first. We're going to compare the quality. We're going to see if there's any speed improvements, because I want to keep the settings are going to be the same. The only thing is I'm going to introduce the LoRa. That's it. Everything's going to be the same. So I'm going to clear this. I'm going to zoom out a little bit so you guys will be able to see the entire command. I'm going to put everything on a separate line just to make it easier for you guys to see this. Okay. So again, we just load the diffusion model, and I wish I could make this. Okay, doesn't matter. Let me zoom out just a little bit more. Oh, there we go. Okay, so that's the model here. You see it's it's 4K. The VAE is the same. Text encoder. The only difference I did is right here. You see the prompt. I added the LoRa. Remember how to add LoRa? You have to put LoRa in this tag and the name of the LoRa, and then the LoRa directory. I showed you guys it's the Comfy UI LoRa's. That's it. Everything else is the same. You see the tile, everything, except this time the output, I didn't put the same output. I put hyphen LoRa just to differentiate it. So let's run this. It says CUDA, but that means ROCm. I said the reason for that is because AMD was very late to this party, so the everything was named CUDA. That confused me as well. So this is the first time I'm using a LoRa on the command line. Normally I what do you call it? I've started using LoRa's in a Comfy UI. So this LoRa I actually just tested it, I think just 2 days ago in Comfy UI. So I am curious to see how fast this is going to be. Wow, that is interesting. Is it done? Or an error? Oh, something went wrong. Okay, something went wrong. Something went wrong. It says segmentation default. What happened here? Dump. Unfortunately, it doesn't tell me what went wrong. Oh, it says here failed to allocate. Failed to. Oh, let me get rid of this. It says WOCM failed to allocate WOCM size. Ooh. Look how much RAM it wanted. Why did it want so much RAM? What the? Why would it want so much RAM? Failed to allocate. Yikes, that's a lot of RAM. Okay, so this must be a bug. Why would it want to use that much? That is crazy. Okay, I might have to drop this That is crazy. Look how much, yeah, that's a lot of RAM there. I clearly don't have that much RAM, you guys, as you can see. So what I'm going to do is I'm going to drop down the tile size. Hopefully that makes a difference. I'm going to grab this command. I think that might be a bug. Oh, you know what? Maybe it's the steps, because this is a LoRa. Oh yeah. This is a LoRa, so I think I need to drop the number of steps. I forgot about that. This LoRa, this is a LoRa, so I need to drop the number of steps. Let me actually see if that will work. Hyphen steps. Put it at 4 steps. No, I'll put it at. I might have to open up Config. I can't remember how many steps I. Oh yeah, let me check my notes. Hold on a second. I'll see what I used for this 2.1. Okay, so for this one, I didn't write it down. Damn. Oh man. Yeah, I have to use less steps. I can't remember how many steps I used though. That's the thing. Oh, you know, let me try. Let's try. Normally I'll try 6 steps. The code will probably be worse. I think that might do it. So let's hopefully that works. Fingers crossed. I don't want to start up Config. I might have to start up Config to see how I got this to work. If it fails, I'll start up Config and see. I'll see what settings I set it up to. Oh, I also increased the. Oh, I just realized. Okay, I think I know what went wrong. I increased it from 33 frames to 81 frames. That's another problem as well. So that makes sense. That's why it wanted all that RAM. The memory. That's why I didn't have enough memory. So I'm hoping by dropping the number of steps, it should be able to finish up. Let's hope so. What the? Oh, I forgot. Oh, what is wrong with me? Yeesh. Making so many mistakes here. One more time. All right. So by default, it goes to 20 steps. So this one I set it to 6 steps. The still one it should be much faster. So I'll see what happens. I might drop it to 4 steps as well. So I think that should fit the amount of RAM. Otherwise, I might have to drop it from 81 frames to something else. Hopefully that fits. Oh, same problem. I'm seeing a problem there as well. Yeah, I already saw a problem there. So how much RAM did it want this time? Hopefully it tells me. It still wants 50. All right. You know what? I'm going to change it back to 30. Was it 33? 33. I'm going to change it to 33. Looks like I can't increase it that much. I guess now we know why people have the Q2 quad size models as well. Come on. So now it's running the steps. Maybe I should have left it at the default 20 steps, because that would have that would probably have been much much better quality. I'm curious to see what it's going to do. Okay, let's make sure there's nothing going on there. Sixteen seconds per iteration. That is actually not too shabby. So one of the reasons it's taking longer this time is because it's also it's building the kernels for next time. So meaning next time you run it will be much faster. So this time it used just 20 gigs of RAM. I'm just curious to see what the quality will look like. Maybe drop it down to, I don't know if I should drop it down to 4 steps, but we'll see. Actually, maybe I should now, because maybe that wasn't very smart, because the other one, when I first ran the 20 steps, it skipped 11 of them, so basically only ran 9 steps. So maybe that wasn't smart. I should have left it as is. Oh, the code is here. What do you guys think? Let me see. I don't know. I think that's. I should have left it at. The 20 steps, I think. Okay, so that's. I'm not too sure. I think. Was that a? Let me see here. I'll run that again. I think that's some quality degradation there. Yeah, that's. You know what? I should have. I'm going to remove the steps. Even though it's a distilled LoRa, I'm going to remove that steps and run that again. I'm going to run it. Yeah, I'm going to run it just the way it is. Just to be fair, because that's not a fair comparison. I mean, you could run something like 2 steps and say, "Oh, look, I ran something in 2 steps." So that quality wasn't good. I'm pretty sure I could probably get something really good at maybe at what do you call it, at 8 steps. But if the quality is not good, so I'll just leave it. So hopefully it has that 20 step from the memory, so it should be fast. And hopefully it skips some of those steps. It doesn't go the entire 20. If it doesn't have to rebuild them. How much RAM is that? Easy cache as well. Okay. Hopefully it skips some steps from previously. It has to rebuild everything. Well, it's also quality, right? Like just because you can produce something really fast, that doesn't mean anything if the quality is not very good. I'm not too worried about this. Hopefully it has the previous cache and it will skip some of the steps. So that's what easy cache and all that stuff is for. So we'll let this run. It might take a little bit longer, but it should drop. I think it will skip some of those steps because it has run it before. Because the prompt is exactly the same, obviously, except with the LoRa this time. All right. So I was actually looking for a claymation LoRa, but I was not able to find one for this particular model. Because most of the LoRa's are usually for not safe for work stuff, or they're for very attractive women, basically human females, is what I'm saying, or they're for furries, and that's not what I'm going for. I was going for obviously just regular stuff, like for example, in this case a cat, or I'm going for say claymation. So I need to be able to do some regular stuff as well. That's why it's like I'm not interested in those things. I'm not making fun of people who are into that. I'm just saying that the things I want to do, and those are not things I want to do the AI image or video generation with. Oh, I have last time I did, I believe, a night stream. When I did the ComfyUI stuff, somebody asked why I haven't done the LX2 video. I did try it, and one thing I noticed, obviously the models are huge and I don't have the RAM. So you see a lot of videos out there, people say stuff like, oh look, you can run this on a 6 gig card, you can run it on a 12 gig card or a 16 gig VRAM card. Now that is true, because all those people, they have like 64 gigs or 128 gigs of RAM. I do not. Okay, and they were saying, oh look, you can run the FP8 version, you can run the FP4. Remember, my GPU doesn't support that, right? I just proved it. So I did try to run some quantized ones, and I realized that I was running out of memory. Yeah, there are probably a few things I can do, but I found that actually inspired me to find this model, the Wan. Actually, no, I tried the Wan 2.25B. I was not able to get a decent result. Even something as simple as this, I was not able to get a decent result. That's in ComfyUI. So I got really frustrated. So then I got rid of it, and then I focused on the 2.1 1.3B. I was getting okay results. Even the base, what is that one? The Fox running one. Yeah, I got some okay results. Then when I was looking for LoRa's, the videos were coming up. People were like, okay, I tried the 5B, terrible quality, and then they're like, but you can run the 14B one. I'm thinking, what are you talking about? It's like it's a heavy model. Then I found out that I was wrong, because it has high noise and low noise. But what happens is, when I think it does high noise first, when it finishes with the high noise, it releases the RAM to load the low noise, or from RAM. So that's why people are able to run it. So I was like, I'm thinking, can I do it so that it doesn't have to be like I can run everything just from the GPU? And sure enough, I was able to find a way to do that. And maybe I'll show you guys next week my workflow. But when I ran both the high noise and low noise, it took like 43 minutes, but the quality was really good. One of the things that scared me was, like, I don't want to run something for like an hour 45 minutes, and then you find out the quality is terrible, or you made a mistake. For example, maybe the color, I asked it to wear like a red dress, it comes like blue or something. So that's one other reason I was not too gang-ho on running them. Okay, so let's take a look what happened here. Did it skip any of this? Did it skip any of them? Oh yeah, it skipped 10. Okay, so it skipped 10 steps. So there we go. So easy cache is amazing. So I can put, so it skipped 10 steps. So basically, so the quality here, I expect this quality to be much better with this LoRa. And you see, so don't be afraid to run 20 steps, because with the easy cache, it skips 10 of them. So that's fantastic. So let's actually go take a look at, also because I'm using a Q4 model. So let's actually run this and see what it looks like. Oh, that must be from the LoRa. Oh, that is actually very good quality. Wow. So more steps does equal, yeah, that's actually pretty good quality. Wow, okay, that LoRa is actually not too shabby at all. The only bad thing is I was not able to increase the, I don't know if it's a bug, I was not able to increase the length of this. Okay, so that's the LoRa. Let's put this back up too. Not bad, that is really nice. I'm actually surprised I'm able to get, I'm actually really surprised with that quality. That's like a wow, okay. That LoRa made a difference. I don't think it sped it up. In fact, our time, what was the time here? It says 3:16, that's over 5 minutes, but for the quality, yeah, sure, that's actually pretty nice. Okay, now, let's move on. What's the next one we're gonna try? Where are we here? Did I close it by next? I hope I didn't close it. Just give me a second. So, which prompt did we run? Is the LoRa one? LoRa, okay, I'll put it back to 33. Okay, so that was the LoRa. Now, we're gonna change things up. Wait a minute here. So I'm confused. This looks like it's exactly the same. That was a LoRa. And oh, now we're going to use the Tiny decoder. So we're going to run the same thing. We're going to use the Tiny decoder. So the Tiny decoder might allow me to actually increase the increase the length. But however, just to be fair, let's set it back to 30. I'll set this one to 33 seconds as well, and we're still going to use the same tile size. So we're going to, so basically what we're going to do is, that was really nice. We're going to do the same thing, except this time we're going to replace the VAE with the Tiny encoder. That's the TAEHV. So the quality should suffer, but what I'm hoping for is, because this LoRa and the 20 steps came up with a good quality. So what I'm saying is that what I expect is, I expect a faster video generation, and the quality should be between this this one and the original one. So everything else will stay the same, except we're gonna replace the decoder. And I'll show you that. Let me make sure I save this. It's clear here, and run it here. So as you can see here, instead of using VAE, we're using the TAEHV, and that was in the VAE underscore approximate, and it's the TAEHV 2.1 down there. So everything else is exactly the same. You see it's 33 seconds, 832 by 480, so it's still 480p. Okay, and you see I gave it a name, Tiny. It's a LoRa. We're still using the LoRa, and then this time it's hyphen Tiny. So let's run that, and then here I'm going to put it back to 35, and let's go. Alright, so let's see what's going on here. And now I'm thinking, with that LoRa, I can probably go with the Q3 KM model as well. Obviously give it more steps. Gives you options. Gives me a bunch of options. I just wish I could pick up more RAM as well. I could be able to run basically any mode I want, but we'll see. Okay, so loading is quick, all the models, and then that easy cache is really good. Again, if this GPU supported flash attention, obviously this will be flying as well. So now I expect some of these steps to be skipped as well, because I think everything is the same except obviously the decoder step. Now the quality, I said I expect the quality to suffer, so I'm just curious to see how much the quality will suffer. and but it should be faster. I'm gonna see if there's an equivalent for that in Comfy UI for the Easy Cache and some of this. I know there's tile. You can put the tiles in there. Of course, you could also run everything yourself using just Python, so you don't necessarily need the Comfy UI. I just like the visual, and click here, and I said, like, once I become more comfortable with that, or if stable-diffusion includes that, I'll just stick to stable-diffusion. So in case you're wondering why I'm using stable-diffusion instead of Comfy UI or some other web UI, it's because this is done in C++. So you get, you don't have to load up all those heavy Python libraries. Or you don't need Python at all. You see, it's just C++, right? So especially when, as I said, some of those features come to this application. Yeah, this will be the way to go as well. It's lightweight, and you saw how quickly I compiled it in the afternoon live stream. So I'm hoping it skips, well, this time it's actually doing 11. I'm wondering if it's going to skip some of them. It's going fast, that's interesting. I think it's definitely skipping some of them. Or maybe it's a tiny encoder, it's just encoding them really fast. Yeah, it looks like, okay, so I guess it doesn't have kernels for the tiny encoder, but it looks like the next time I run this, it should fly. So so hopefully it takes up less. Wow, that is actually pretty fast for this tiny encoder. So I remember I took away the VAE and I'm using this tiny encoder instead, and as you can see, it flies through 20 steps really quickly. It's already at 19, and that's actually pretty acceptable. 12.23 seconds per irritation. That's really good. And remember, because of the Easy Cache, next time I run this, it's actually going to be even faster. The first run is slow because it has to generate all those kernels, but I'm saying is now they're going to be in cache, so I might actually be able to increase the number of VFrames. Oh yeah, it did skip 10 of them. So that's fine. Yeah, I love Easy Cache. Oh. I was a little bit TAEHV compute buffer size. It's taking up, what is that, 59? Oh, it's done. Oh, the quality doesn't look bad. How much time did that take? 286. Is that the fastest so far? Wow, that might actually be the fastest so far. Yeah, that might be tied with the other one. So let's see what the quality. And this is also using the LoRa. So let's actually see the quality of this guy. Not bad. I don't see any. Do you guys see any artifacts? I don't see any artifacts. Let me go for a closer look. I don't see any artifacts. Wow, that is good. That is good. So there you go. If you guys want, I'm gonna actually try. There's a reason I got this tiny encoder. So There you go. So if you want, if you're having problems with the decoding step, use the tiny one. The tiny one gets rid of a whole bunch of stuff, and obviously, especially when you're using a quantized model, now the code will suffer, but this is good. I'm very happy with this. Okay, now the tiny encoder, yeah, but we still haven't increased the size yet. So, but the tiny encoder gives us hope that we're on our way. Now, what we're going to do next is we're going to increase the tile size. So the tile size should speed up the VAE decoding step as well. So that's what we're going to do next. And what I'm going to try is I'm going to try the can I do the 5-second yet, or what's the difference between this one and the last one? Okay, yeah. So I'm going to try to increase the I'm going to try to increase it to 5 seconds as well. Hopefully it doesn't run out of memory again with a tiny encoder. So I'm gonna change it to 256. I'll show you what the difference is, and we'll take a look at it. So let me clear this. So the difference between this and the last one is, besides the the name here, tau 256, you see, all I changed here was I set it 256 by 256, and I also changed the video frames from what was it, 33 to 81. So this should be 5 minutes. So let's run this, and hopefully it's able to run. I might just double it. I hope it doesn't need that much RAM, because I'm using a tiny encoder and the tile size is much bigger. So we'll see what it will do here. See, that's the reason I was telling you guys, like, if you use the Q4KM, the quality, it's a medium, it's a good compromise, and yeah, so it should be fine. Okay, hopefully they don't know. Oh, looks like, yeah. Okay, I ran out of memory, so it doesn't like this. So let me change it to maybe 3 seconds. What would be 3 seconds? 16. What is it? You know what? I'm gonna go for 4 seconds. 16. Oops. 16 times 4. Come on. 16 times 4 is 64. I'm gonna go for 65 seconds here. 65. I'm gonna try 65. That should be 4 seconds. Hopefully that works. Paste. Did I clear it, or did I not clear it? Yeah, this says, all I did, I changed it to 65, so that should be 4 seconds instead of the 5 seconds. Basically double it. Let's see what's going on here. I should definitely be able to do 3 seconds at least. Or another option is I can do 2 seconds, and just attach them together. So will this work? Okay, so this one is also a problem. It wants too much. Yeah, so that's not going to work as well. So what I'm going to try is maybe 3 seconds. Let's try 3 seconds. 3 times 16 is 48, so I need to put 49 here. So this is 3 seconds. This should be fine. That should not be a problem. That should fit in the, that should that should fit inside there. 3 seconds should fit. I don't. You know, one thing that I would like to find out is why the Wan models, yours have to give it one extra frame. Now I'm saying it makes it smoother, but it's kind of ooh, oh, yeesh, yeesh. What happened here? What happened here? Core dump. What the? So it can't do more than 2 seconds? Well, okay, I guess we'll have to go back to 33 then. I'm kind of a little bit disappointed. So I can't do more. Alright. Where are we here? Okay, so if we can do more than 3 seconds, I mean more than 2 seconds. Was that 6? I can't remember what number that was. So in case you're wondering, I just changed it back to 2 seconds. Where am I here? Yeah, I just changed it back to 2 seconds because 3 seconds failed. Oh no, sorry. What am I doing here? What? I'm confused. I'm confused here. Why is it? Oh, did I do it twice? Is that why it? I'm super confused here. I don't know why it's. Oh, okay, yeah. It's so confusing. All right. Oh, it repeats what I did. That made me really. Oh, looks like. Okay, so looks like that must be a bug. It looks like you can't do more than 2 seconds for some odd reason. Yeah, so that's clearly a bug. It's not. I said it's clearly capable of doing at least 3 seconds. But I said you can just basically grab the videos and just stitch them together. So since I know that I can't set this, I'll set this to 33 as well. So I want to see if this is going to be any faster. So after this, there will be one more test to do, which we'll set the tile size to 512 by 512. That will use actually less VRAM. But I said there's a slight performance hit as well, but it's most likely worth it. What time is it? Oh, it's almost 2 hours. Wow. Thanks for you guys if you're still watching this, if you're curious. So I expect this to also skip a few steps. Hopefully it skips about 10 steps, and then yeah. So I love that easy cache. I'm gonna be obsessed with the easy cache after this live stream is over. You clearly know I want to get that working on in Comfy UI as well. I love that. That made this model really, really, really good. Yeah, it's clearly skipping some steps, so that's good. Hopefully it skips the next 9 steps, or however it does it, doesn't really matter. That is actually very good for prototyping. So as I said, I wasn't able to get a LoRa that supports this little guy, because most of those LoRa's are probably on the 14B. Well, I said they're not safe for work stuff, which I'm clearly not interested in. I'm more interested in stuff. I'm not interested in cats. I'm just saying that I'm interested in, I said, claymation and like if I want to do stuff like, for example, when I edit a video, I would like to maybe either generate some animation or something like that. So that's what I'm more interested in, not the other stuff. All right. Okay, so I'm curious to see how much time this one's going to take. So one thing I did learn is that if you want the best quality, obviously the more steps. So it is worth waiting, as you saw, like compared to the general A Lovely Cut. It's the same prompt, but if you get a LoRa, it will be, it will make it pop out. As you saw, the cat looks way more realistic than the other one. The other one is kind of not quite grainy, but not as the quality wasn't there. And then when I added the LoRa, wow, it just made it really, really nice. And this Tiny encoder, this also has me really, really, really happy. Yeah. So clearly it has to build kernels for this one, because yeah, it's done. How long did that take? 275. That's a new record. 275. It's actually faster. 275. That's the fastest so far. What is that? That is, yeah, that's the fastest so far. So let's check the quality of this one. This one, you see, it's 256. So we're using 128 by 128. So what that tells me is that if I actually go down to 512 by 512, this should be faster still. Okay, and no quality. Obviously, I don't expect any quality degradation. So I'll play it for you guys here. Yeah, not bad at all. All right, so the last test, we're gonna set the tile size to 512 by 512. I'm kind of questioning that one because remember, this is what do you call it? This is a 480 480p model, but we'll continue on with that as well. So let me clear this, and again you can see the video frame set to 33. For some reason it's not able to go higher than that. And then you see the tile size set 512 by 512. So let's run this. I think I read somewhere where the leadjet was saying that this model, where am I here? I think leadjet said something about this particular model. Oh no, I think it was in issues or something. Someone was asking if they can create a longer length video. Let me actually see if leadjet was able to actually do it with any other model except for this one, besides this one. So this guy is running. Where is Wan? Where's my Wan? There we go, Wan. Flow shift video. I think all the videos are 33 seconds from what I can tell here. Yeah, all the examples are 30. So this one doesn't have a second thing at all. Interesting. Text to video for 2.1 doesn't have 10 steps, high, blah blah blah. 8 steps. Doesn't have Wan 2.2. Yeah, all the examples have 33 seconds. I'm wondering if that's a limitation of the application. Or maybe because I'm also using the Tiny encoder. That could probably be it as well. I'm not sure. But yeah, the Tiny encoder, I'm really happy with it. The results are really good. I'm glad I actually kept this model. I was actually gonna get rid of it. I'll also, after this one, I will see if I wonder if I can make like 3.5 frames. What is half? Let me try 3.5 frames. I'll see how long this one takes, and I'll see if I can do a 3.5 frames. That shouldn't be a problem. So 3.5 times 16 is 56. I'll try maybe 57 frames. See if that works. So let's try 57 frames instead of the I drank so much water today, decided to be very cold in here, and I'm surprised I didn't. Normally when I drink that much water, I always run to the washroom, but I think because it snowed yesterday. Well, it snowed all day yesterday. I was out in the morning, I cleared the snow, and then today I had to go in the morning, clear the snow, go to the farm to get groceries, come back, look after the chickens, and come in here, have breakfast, and then I think, did I do some work as well? Yeah, I think I did some work, and then next thing I knew, it's time for the live stream at 2 p.m. After that, there was a customer called me for a quote. I provided the quote, added the videos, and it was cold in here, but I was drinking a lot of water, and then I'd cook dinner, have dinner. Next thing you know, it's like, oh, night stream time, and there we go. I'm really liking the Easy Cache. That's definitely a keeper. That's definitely a keeper. Man, I just wish the memory prices would go down. It's really hampering my ability to try out some other type of models, but the good thing is you guys will benefit because I'm basically limited with RAM, and I have to come up with tricks like this to yeah, I have to come up with tricks like this to what do you call it, for low RAM. So there we go. The quality should be still fine as well. So how much? Oh, this one took a little bit longer. Yeah, this one didn't surprise me because as I say, it's a 480. So 512 is actually bigger than this one, so it probably had to do some finagling in the back there, but the quality should still be good. Yeah, so no problem with the quality as well. Yeah, so no problem with the quality at all. So again, yeah, no problem with the quality. So basically, when I started using the LoRa, no problem. It was faster as I expected. Now there's no complete LoRa that not LoRa. There's no distilled model for 1.3B. I guess because it's small enough, nobody's actually created that distilled version or a turbo version. That would have been nice. I would have loved to try that. Obviously, this would be faster, but that's tiny. So don't be afraid to try the Tiny encoder. Wow, big difference. And obviously with the LoRa as well, you get really nice quality. Now, as I said, I'm very stubborn. So I'm gonna run. I'm gonna call this one. I'm gonna run the 5. You know what was the best one? I think 256. I'm gonna run the 256 one again. That was the fastest so far, which makes sense. I could probably do a 384 as well, or even a 480, but I was okay with 256. So what we're going to do, we're going to run the 256 and we're going to put 57 for 57 seconds, no, 57 frames. I'm going to try that one. Yeah, so you see here 480 by 480, that was the LoRa, 480 by 480 or whatever. So so I'm guessing if I maybe make this 480 by 480, but it's not. Yeah, so I don't know, maybe that will obviously be faster. That will be a perfect square. So that's another thing you can do. You can kind of reduce this, but oh yeah, that's true. I can actually reduce because the quality is so much better, I can actually reduce the resolution. I didn't even think of that. That's something I just thought of right now. Let me try. Let me see if this works for. Let me see if this works first. If it does, I can reduce it to 480 by 480. I'll try that one. So this one is a 3. This should be 3.5 seconds if it actually continues and doesn't. No, what did I say? Wait, I'm confused now. Oh yeah, I meant to put 2.5, so it looks like I can't go above. Yeah, okay. So I don't know why I did 3.5. I meant to do 2.5. Anywho, so that didn't work. Oh, yeah, no wonder it didn't work. The name was wrong. That should have been 256 by 256. Okay, so I'm gonna change the size to 480 by 480 because of that LoRa. And I'm going to increase. You know what? I'm going to try that. Let's see. Run. I'll show you the changes I made. Hopefully this does work because now it's going to be a square. So what I did was I changed the width to 480, the height to 480. The frames is 57, so I think that's a 3.5 seconds. And I changed the tile size 256 by 256, and you see here I set it to 256.57. Okay, let's see if that actually does anything. It might take a little bit longer, but if it actually does work, that will get out of the jail, which where it looks like you can't do anything over 2 seconds. So this should also be much faster, even though I'm already using the Tiny VAE, because it doesn't have to do as much. I would actually not even be surprised if it's actually double the size, because it doesn't have to do that. Was it 832 it was? Okay, so far it hasn't oh, okay, it hasn't broken up yet as far as I can tell. Is it going to do anything? Oh, okay, there we go. So that width was a problem. So okay, excellent. So there we go. Finally. I was afraid I might have to change the title when I said the length. We'll make it longer. So here we go. This is the one that is the one that is longer length. So when it finishes, this will be a perfect square, 480 by 480. That was what the LoRa was trained on, it seems. So the height should be fine. I'm just curious to see what it would look like. Even when it was that wide angle one, the cat part only took up basically a square. So I guess that might also be because of the LoRa. Not sure. Okay, so we'll let this guy finish, and that will be it. Yeah, because now it's over. This has been going on for over 2 hours. This will be the last one. All right, so hopefully this goes quickly and we'll finish it up soon. Drink of water. While that's running, I want to check the chats. Okay. All right, so man, even my water seems a little bit warm. Okay, so is it skipping anything here? Looks like it's going a little bit faster. Maybe it has to drop some kernels as well. I mean, create new kernels. Okay, it's 18, so I think it hopefully did skip some of the steps. And oh, the temperature is a little high too. I need to let me increase this. Didn't realize the temperature is that high. Let's use it to 45. I guess it was running fast enough. I wasn't paying attention to the temperatures there. Okay, so one more, and then okay, so now it's doing the tiny encoder. And it's done. 256. I think that's a record. Well, obviously that's a record. So let's get rid of that too. Alright, so let's check out. This is going to be a square video, of course. If the quality is good, I think this is a success. We got longer time. Let's talk and let you play the video. Wow, I like that LoRa. Wow, glad I used that LoRa. Okay, so there we go. So this turned out to be much better than I expected. I am actually blown away that the tiny encoder worked extremely well. So I'm going to be using that tiny encoder in ComfyUI as well. So quick summary, use a LoRa. You guys saw the difference it makes. Like, wow, makes a big difference. You can and what's the other thing you should also do? Yeah, use the cache. And then obviously I always keep on repeating this. Make sure you understand the limitations of your GPU and what your GPU is capable of, and then that way you won't have headaches and you can speed up your workflow. So I'm really happy with this. See this, it actually says right there, it's 3.5 seconds. Very good. Play it again. Very nice. Very nice. Now clearly this model, the 1.3b, sorry, the 2.1 1.3b, it was only trained on 480. So if you need 480, you know, like you saw the 480 stuff, it will work very well. Of course, there's some LoRa's which can improve, and then you can scale it up. But yeah, it's perfect for prototyping. Now, I want to give you guys a sneak peek into some tutorial that's come probably next week. So let's just take you out of here for a while. I'll give you a little sneak peek. Should I give that to you, or should I just leave it? No, you know what? I'll just leave it for next time because this is too long. Let's finish this up. Okay, so this is our cat. Let's get the not get rid of it, but put our cat there. Can I leave this in a? Where's the loop? Is there a loop here? Repeat. There we go. So keep on repeating. Okay. You know, it would be nice if you went this way and this way. That would be really nice. Left, right. Then it will just move closer. Okay, so to finish this up, you can take your skills further. I have books. They're available on Amazon. You can search for Ojambo. The link is also in the description. I have courses on ojamboshop.com. The link is also in the description, and I have services, for example, tutorials. You contact me at ojambo.com/contact, or if you need consultation services, at ojamboservices.com/contact. And I also have some other recommended resources. I live in a rural area. There's no internet here, and the cellular service is very sporadic. So I use a Starlink residential service. If you're thinking of getting this, please use my referral link for the SpaceX Starlink residential service. I'll get 1 month free, and you will get a significant discount. I also have this. It's the Honeywell HeatBud Personal Ceramic Heater. You see it has a low and high setting. The low is 170 watts, high is 250 watts. So it's not meant to heat up the entire house or even the entire room. It's just meant to heat up your personal space. My personal space is this right here. So this guy is fantastic. It allows me to set the temperature. Yes, it's in winter. We're in winter, and I set the temperature to 14 degrees Celsius, and this obviously I dress warmly as well, and this guy keeps me warm. In fact, even during this live stream, it's been over 2 hours. I haven't even turned it on yet, so I'm perfectly warm. And you can pick it up on Amazon. This is my affiliate link. I'll get a commission, and it's no extra cost to you. I also have this. It's the Algorithmic Serpent. It's a novelette by me, Edward Ojambo. It's about a scientist who creates an AI system and loses his mind. So he has to regain control of his mind and the AI system. This is the paperback version. It's available on Amazon. Pick it up if you have the means. There's also an ebook version. You can get an ebook version for free if you have Kindle Unlimited. My greatest one is the Recession Business Blueprint. This is a guide to help you start a business during a recession. The best time to start a business is during a recession, and we are currently in a recession right now. So if you need help, or basically if you are an entrepreneur, this is the best time to start. The Recession Business Blueprint has everything you need, whether you need help budgeting, accounting, contacting suppliers or customers, or business ideas. For example, one of the growing businesses, even though people are predicting that it might go bust, is the AI workspace. So that could be something you could do. You don't have to be an AI expert. Maybe you just bring people together. That could be your go-to business, right? So yeah. So there's a lot of opportunities for that. So pick up the Recession Business Blueprint. It's also on Amazon. There's the ebook version and the paperback version. For all my books, the ebook version you can get it for free if you have Kindle Unlimited, and not all of them have a paperback version, but the Recession Business Blueprint does have a paperback version as well. Okay, if you want to know more about me, I have a blog for every article I write on ojambo.com. I'm a freelance programmer, software engineer, web developer, and author, of course. My book page on Amazon, the link is there. As I already said, it's also in the description. If you need support, you can contact me on ojamboservices.com. The link is also in the description. And if you're ready to learn, you can go to ojamboshop.com for the online courses. The link is also in the description. So if you want to contact me, you can leave a comment. Use a comment form. Make sure it's related to the topic. For example, this topic we've done here today is about AI, stable-diffusion, the Wan 2.1, 1.3b model, and LoRa, cache, all those are perfectly fine to put in the comment section. But the best way to contact me is use the contact forms, ojambo.com/contact, ojamboservices.com/contact, and ojamboshop.com/contact. And if you want to follow me, I live stream every day to Odyssey, Rumble, BitChute, and YouTube. Now I'm going to show the outro, and we're going to go right about here. And I'd like to implore you to subscribe, like, follow, and leave comments, because the more people subscribe, the more the algorithm sends out to more viewers. Those viewers can join this growing community and post tips and tricks, or they can post requests, which I'll go and research and I'll share with everyone. For example, when I started this AI journey, I didn't know anything. I just got the GPU, I upgraded my workstation, and viewers actually helped me. So when they helped me, I didn't understand anything, but I'm saying is that on my own, I went and did research. Now I'm very good at it, especially this GPU. I probably know more about this GPU than even people who got it, some influencers just a few years ago. I know way more about it. Not because I'm not saying that their work wasn't good. I'm just saying that I was able to do research, find the limitations, and I say it's not a simple copy pasta. You have to know the limitations and you follow them, and you'll be able to generate it. You see, for example, people will tell you that, oh, don't bother with the Wan 2.1, 1.3b model. It will give you horrible results. But you can see what happened here today. Not only did we speed up the video generation process, we also found a LoRa, and you get a more realistic looking cat and pretty good quality. Remember, I was saying it decent? That's pretty good quality, right? So if you want to know more, you go to ojambo.com, you go to watch menu, live summary. You can see we have the upcoming topics. For example, the topic we did today is obviously not here anymore, but this is what we're doing tomorrow. It's self-hosting. This is a very important one for some of you guys who want to use the Vault Warden, and show you how to set up using Podman desktop. You don't have to touch a command line, don't worry. Everything we just use this Podman desktop. It's a desktop application, and we're also going to set up Nginx proxy. So this will create the self-signed certificate, or if you actually put it on your remote server, you can use Let's Encrypt to get a proper validated certificate. Then the day after that one, we have this one. We're going to look at Vim. Don't worry, it's going to be 5 commands that you need that will help you become much better using Vim or the command line as well. And if you notice, most of the IDEs, they always have a Vim mode, so this will turbocharge your coding knowledge. And then after that, we're going to review this local send. It's another application where you can send files between your devices, whether it's your computers, your laptops, your phones. Local send is cross-platform, so we use that. The reason I use this because you see I do have a phone, right? I do have a phone here, but the problem is I've been plugging in and out with the USB, and what happens is the computer, the front ports, they're kind of I guess bent or whatever, because I'm still using the old case. The case is pretty old, so I think the connections are kind of wonky. So it's kind of a nuisance to always plug in, plug out. So if this wireless one, because I use Wi-Fi calling as I explained before, so that makes it pretty nice. And then after that, we have this Blender Python. We're continuing the series where we're creating like game assets or assets for a web or anything like that. So we're going to create procedural landscapes, and then after that we'll do some other AI stuff where we will generate pyramids using local AI, and then we're not going to judge it. We're just going to run it the way it is, and then the day after that we will review it and fix any issues, especially optimize it as well. So that's all that's upcoming, and yeah, so I don't see any chat requests, so what I'm going to do is I'm going to end this chat, and I'll wish you a good day, good night, and I'll see you tomorrow.